Hi, welcome to Pump Flow Screening Systems presentation. My name is Serdar Umur and I am with the Headworks Center of Excellence in the Parkson Corporation. Today we'll discuss the screens with you and what a screen is, and municipal and industrial uses of screens and benefits of screening in different applications. Then we'll get into pump flow screen types and what Parkson's offerings are in this area. And then we'll look into municipal applications and industrial applications, and then also look at solids handling. What do we do with the captured solids after we screen them out? First, let's look at a screen. What a screen is, and screen is basically a defined opening with that allows us to separate solids from liquid streams, and it only can remove solids that are larger than the screen opening. Here we see a pencil that you see lined up parallel to the screen opening, and it's not passing. But if you lined up right, it could actually pass the screen opening, and that's why it's very hard for us to estimate what a screen's capture rate capability is. We see here different screen media types that's used in our industry very often. There are slots, bars, Wedgewire, and perforated plates and woven wire mesh. The main difference between the two is slots can be different directions in X and Y directions, as you can see there, and the perforations and woven wire mesh is typically just the same dimension in both directions. In a municipal application, municipal wastewater treatment plant, screens are typically used in headworks, at the headworks area, what we call is a preliminary treatment step. And in industrial applications, they are used to reduce the cost of water. As we know, every industry produces a product, and to do this, typically many industries uses water, and they purchase this water coming into the plant. And then it turns into wastewater, and that actually they have to pay another money to discharge this water. So does it make sense to use an internal pre-treatment? Absolutely. And most of the wastewater treatment, most of the industries actually have internal industrial wastewater treatment plants, either fully treat the water or partially treat their water and send it to a collection system. Or some plants just decide to send it directly to municipal wastewater treatment plants. Here are a couple steps that the industrial plants uses their water as part of their process. It can be at the receiving, washing, packaging, or at the end, cleanup. They always use water. And how does screening help to industrial plants in this process? They basically reduce the water coming into the system and coming out of the system. At a washing step, if you can screen and create recycled loops, you can use this water again and again instead of buying new water into the industrial plant, and this saves a lot of money at the end. So what are the benefits of screening at a wastewater treatment plant? Here we see a condom stuck on a weir, as you can see. And this is how did that solid come into the clarifier. It basically, the plant either didn't have a screen or the screen was not adequate enough to capture that solid. So what's going to happen to that solid? It's either going to pass over the weir and end up in the outfall going into a river stream, or it's going to just settle there and mix with their sludge, and it will reduce their sludge quality. So the first benefit of screening is removing troublesome inorganic solids from the stream. The second benefit is to protect downstream equipment. As we can see here, in an aeration basin, a diffuser pipe is coming down and there are a bunch of rags stuck on it. These rags typically end up in the pumps or filters, and they break these equipment down. And it takes a lot of money, time, and effort to fix them back, bring them back on, and some downtime. So we don't want that. And if you had an adequate screen, these rags won't be there, and you won't have downtime. The third and one of the most important also benefit is enhancing downstream process. Here is again an aeration basin full of rags and solids on top and inside. And you can imagine you're trying to pump air and keep a dissolved oxygen level in this aeration basin, and you can imagine how good your transfer efficiency is, air transfer efficiency is at this level, so in this aeration basin. So if you had an, again, adequate screen, you wouldn't see this scenario. And again, the same thing, overloaded clarifier full of solids. This is totally not acceptable. And with a screen upstream of this clarifier, you wouldn't have this, you wouldn't see it this way, and it would be all clean. So getting into screens, pump flow screen types, in Parkson Corporation, we utilize two types of screening media, Wedgewire screens and perforated plate screens. We have 3 screens in the Wedgewire area. It is Hydroscreen, the static screen we call it, Rotostrainer, and the Rotoshear. And the Rotoshear PF is our new screen that utilizes perforated plate media for its screening. What is Wedgewire? Wedgewire is V-notched and teardrop bars lined up next to each other, and they capture everything that is bigger than the screen opening. And Parkson offers slot openings starting from 100 thousandths of an inch down to 10 thousandths of an inch, which is also 2.5 millimeter to 0.25 millimeters. So the first screen we're going to look at now is the static screen, Hydroscreen. Here we see a schematic of the Hydroscreen. Basically, the flow is pumped from the back end of the screen. As you can see, the influent comes in. The flow fills up, the water fills up the influent head box, and then it moves on top of the weir and goes over to the screening media. We have a swing baffle, what we call, which allows to distribute the water evenly on the screen media. And then our parabolic screen media, screen design, allows water to move down by gravity, and clean flow goes into the collection pan and goes to the next process, and captured solids moves down on the screen media and captured into the dumpster or conveying equipment. Hydroscreen has different models, starting from 18-inch screen width to up to 120-inch, 10 feet long, and the abbreviation in the Parkson Corporation is HS. Some Hydroscreens are always built of 304 stainless steel or 316 stainless steel. We have inlet and outlet pipe stubs or also optional flanges, and we can have pivoting screen panels to clean the screen from inside out. Some of the important Parkson features that nobody else offers is custom headbox design for different applications. We have a flow distribution baffle that I discussed that evenly distributes water over the screen media. We have a drip lip which allows drier solids to be discharged. And we have the bi-wave screen panel, which is very important that we see here, that basically cuts down the resistance while the flow is moving down on the screen media compared to a straight Wedgewire design, and increases the hydraulic capacity. Here we see 2 applications on a brewery plant and a corn cannery that is utilizing Hydroscreens. And another municipal application in Goodyear, Arizona, we see 4 Hydroscreens with our Helix press conveyor, and then our ram press for compacting solids. Our next screen that we're going to discuss is Rotostrainer. It's called externally fed rotating drum screen. The operation of the screen is basically the influent comes from the back end again and fills up the head box, and we have a U-shaped head box there. You see the baffle again in the middle, which slows down the water coming into the screen and permits it to evenly goes over the screen cylinder, the round screen cylinder. And then with the force of the water, solids stick onto the screen cylinder and the cylinder continuously rotates on one direction. And the green part there that you see is called the ductor blade, which touches to the screen cylinder and scrapes off the solids that are captured. And the clean water passes through the screen media, and it's collected in the effluent collection pan and goes to the next process. The screenings again goes into a dumpster or goes to a conveying equipment that's another equipment. Again, hydraulic, we have many different models for Rotostrainer. We offer starting from 25-inch in diameter with 12-inch cylinders, very small units, up to 36-inch in diameter and 120-inch in length, 10 feet in length. And the abbreviation is RSA for Rotostrainer. Some of the important features again for the Parkson's Rotostrainer is we offer an overflow connection, which is very important that not a lot of other manufacturers can provide, that helps the plants if they have very variable flow rates, that they don't have to upsize and buy the biggest unit, but they can basically control their flow rate with this overflow connection. Or the second important feature is again automatic ductor blade cleaner. If the solids are sticky in your application, typically they tend to stick on your primary ductor blade that scrapes off the cylinder. And if you have the automatic ductor blade, every rotation it goes over to the primary ductor blade and it scrapes off the solids off the ductor blade and cleans it off. This improves the operation significantly. We also have food grade or clean in place designs available for different applications. And Rotoshear is our internally fed rotating drum screen. Here is the operation of the Rotoshear. It's different than Rotostrainer, as you can understand from the name. The water is introduced to the cylinder from inside and goes to the clean water goes to the outside of the cylinder. As you can see, influent comes from the front end again, and there is a top style head box in the front, which again has a baffle arrangement there that slows the water down. Then it goes over to the orange distribution pan that you see, and the water flows on top of the screen cylinder from both sides of the distribution pan, and then the captured solids are removed to the end of the discharge end of the cylinder by the flights that is welded onto the cylinder. The green piece there is our spray system that continues to wash the screen from inside and outside, which creates a backwash basically, and it can be used intermittently. It doesn't have to be continuously to save water. Rotoshear has many models, again, starting at 24-inch in diameter, goes up to 80-inch in diameter. It is it's the screen that can handle the highest flow rates up to 13,000 GPM at one screen. And it's our most selling screen basically. Here's a typical installation at Logan, Township, New Jersey. As you can see, we recommend engineers to build containment curbs around the screen. And here the engineer didn't want to use a channel, so he put a drain pan and a pipe effluent to the screen. And we have support legs, as you can see. So one of the main advantages of the Rotoshear screens is the head box design. Our head box design is very unique compared to anybody else in the industry. We offer custom designs per application. We have the top style and Medloff style head boxes. The upper left corner that you see is our top style head box with a big box in front of the screen that you see, which has the baffle arrangement in the front. And the bottom low one is the Medloff style head box that is for industrial applications typically, and it doesn't have that baffle arrangement. Why is this important? Because top style head box is good for high flow rates with lower solids concentrations. At a high flow rate, you have to control the water coming into the screen so it just doesn't shoot out at other end of the screen. It evenly distributes over the screen. And typically, they are good for municipal applications, and the weir length is always 2/3 of the screen cylinder length. Medlow style comes from medium to low flow rates, basically, and it's a flatter head box. It's smaller, and it's good for medium flow rates and with high solid concentrations, typically used for industrial applications. And the weir length changes over time with the solids concentration. I want to talk to you quickly about our new features that we added to the Rotoshear within the last year. We designed it with the operator in mind, talking to our customers and asking them how we can improve this product. It's a 30-year-old product and with many installations, but it could, the operators would benefit some of the improvements. So we did this, we looked at our drive system, all the moving parts basically. We looked at our drive system, trunnion wheels, stabilizer pads, and our spray system, and we did design changes on all of these pieces. I'm not going to get into details, but at the end, I want to show you the results of these improvements. That at the end, all of these improvements cuts from maintenance time, basically. And any competitor unit right now requires about an hour, hour and a half in attention a day for their unit. And we eliminated all of this by Rotoshear Easy Care. And when you add up the numbers, it almost comes to $10,000 a year of savings, which is very significant. And in 20 years, you can save about $180,000. Depending on the screen size, it would be 1 or 2 screens for free. So that's I think, very significant and important. Getting into Rotoshear PF. Rotoshear PF is the same screen as the Rotoshear. It has no difference, but Rotoshear PF uses perforated plate media instead of the Wedgewire media. Wedgewire is typically used for primary screen, as a primary screen or slice screening, and perforated media is used for pre-membrane screening. Some of the important features of the Rotoshear PF is the cylinder design is different. It uses a skeleton frame for maximizing the open area on the perforated plates, and we offer 1 millimeter or 2 millimeter openings. And it definitely has higher capture rates for fibrous material, and it is typically, again, used for protecting membranes. Some of the benefits of using rotating drum screens or Rotoshear in your wastewater treatment plant. These are the only type of screens that can claim that 100% protection. They never have bypass compared to other screens. The screens with seals in the channel or they have moving belts, they can carry over solids, but rotating drum screens never allow this. They have higher capture rates, better product recovery because they can offer finer openings down to 0.010 of an inch. The housekeeping issues are less with Rotoshears because they are totally enclosed, and odors are stay in the screens. They are not outside, that they can't get out of the screen. You don't have to build channels or primary clarifiers by using rotor screens. All moving parts are above or away from the water, so you don't have any submerged bearings that can cause problems. And we have interchangeable drums, so if you need to improve your, increase your capacity or change the biological process, you can easily change the drum only and achieve this goal by not changing the whole screen. So some of the municipal applications that we use rotor screens is the raw sewage screening as a primary screen, membrane pre-screening, sludge screening, or the Scum screen. Getting into a little bit detail, here we see a Rotostrainer as a raw sewage primary screen. And we typically use 60 thousandths of an inch to 100 thousandths of an inch openings at the municipal applications. There can be possibly a coarse screen in front of the fine screens, and we use them in lieu of primary clarification. And typical removal rates of these screens at a municipal application is up to 25% of biological oxygen demand or up to 30% of total suspended solids. Here now we see a Rotoshear, two Rotoshears as an influence screen at Cumming, Georgia plant. They are feeding into our HyPress unit there, you see. And at the same plant again, they are using it as actually sludge screens in Cumming, Georgia. 3 of our units feeding into a Helicon conveyor and then a Aqua WashPress. Here, Rotoshear again is a sludge screen at Houston, Texas, at the 69th Street wastewater treatment plant. We have 5 of them there, and each of them has a capacity of 4,200 GPM, and they're screening up to 1% waste-activated sludge at this plant. One of the most important features or benefits of rotating drum screens is that you can use them in lieu of primary clarification. There are hundreds of installations in the industry this way. It's an accepted practice by WEF's Manual of Practice book, and McAfee also talks about this. And different size openings yields to 30% of again total suspended solids removal and 25% of BOD removal. Here is a study that was done by HDR for City of Hamilton in Montana. And here fine screens cost actually 60% less over a 20-year study than building primary clarifiers. Clarifiers would cost about $5 million, and if you had fine screens instead, you would only spend $2 million for capital cost and also for operating them. Here is one of our installations this way. These were installed in 1985 at Lewisville, Texas. And also I have these calculations available that these screens cost 50% less than building primary clarifiers at this plant. And another application that we see here is Rotostrainer as a Scum screen. As you can see, not every wastewater treatment plant has very adequate headworks. So the solids pass the headworks and then they have primary clarifiers, and a lot of solids tend to float, and those are skimmed off of a primary clarifier. And then Rotostrainers are very good with high fat, oils, and grease levels, so they can handle these greasy solids and screen out the solids out of a floating primary clarifier. Here we see some good pictures. Those are solids on top of on the left, on top of the clarifier, and then they went through a Rotostrainer and also washing, dewatering equipment, and you can see how white and clean they are now. Typically, we use 60 to 100 thousandths of an inch openings again for these screens, and we derate our screens, and we also recommend hot water spray in this application because you don't want fat, oils, and grease to coagulate on the screen media. Another important application is the Rotoshear PF. Right now, upcoming and growing application is definitely membrane bioreactor screening. These are definitely, these criteria comes from membrane manufacturers. This is everything they want in front of their membranes, because membranes are still very expensive and they give long terms of warranty. And if they're not protected right, they have to spend a lot of money on their warranty costs. So they are telling us they want to protect their asset. They want only 2 millimeter or smaller mash or punch hole openings. They want to design for all flow conditions. They want redundant screens. They don't only want one screen. If one screen is down, they still want to be able to operate. And they only want center feed screens with no screens carryover and bypass. And as I mentioned, only rotary drum screens can, especially Rotoshear PF, can meet all of those criteria, especially the no bypass criteria. Here we see an installation of the Rotomash pre-membrane screen system installed in Oakley, California at Ironhouse Senator District. This plant uses 2 Aqua guards as a coarse screen 6 millimeter openings, and then they have our Rotoshear PFs, 3 of them at 1 millimeters fine screen, and also our dewatering and washing equipment. So getting into industrial applications. Industrially, rotary screens are used a lot in food processing, mainly in food processing, food and beverage industries, as I said. In paper mills, we see plastic recycling coming up, and also petrochemicals, rendering, and textiles industries use rotary screens commonly. So here we see a general schematic of a food processing facility. And here's a transportation step, for example, that you can utilize a Rotoshear. Here we are seeing a cranberry processing facility, basically. And here, after they harvesting the cranberries, they bring it into this pond, and they transport it by using these nozzles and spraying water into the nozzles, into this pond. And after the cranberries are transported, how do they separate it? They separate it by using Rotoshears, and they reclaim the water and then just spray it back, bring it back, pump it back to these nozzles. By doing this, they are saving a lot of money by not bringing new water in. This is one way of using it. Here we see screenings of potato chips, basically, French fries at a Carnation facility. Again, it's another application. Here we are seeing after the chickens are processed and their feathers are taken off, they wash the feathers down and they just send it to our screens with water, and then we reclaim the water and separate the feathers as a byproduct. Getting into solids management. So what do we do with the solids that are captured by these screens? How do we handle them? And why do we handle them? Municipally, the first thing to look at is the liquid restrictions. If you have free water in your screenings, you cannot take it to landfill. You cannot just discharge it as it is. So you have to get rid of the free water per regulation from your solids. So how do we test this? How do we know we don't have any free solids in the screenings? It's called the paint filter test. We basically take 100 gram of dewatered sample, we put it in a paint filter in a funnel, and then we wait for 5 minutes. If there isn't any free liquid in the water, in the solids, then you are good to go. You can landfill them. Otherwise, you just have to compress them more and dewater them further. So how do we achieve this? We have conveying, washing, and dewatering equipment available in Parkson Corporation. We have mechanical conveyors and compactors, shafted and shaftless spiral designs, and a hydraulic piston design. And we also have sluicing and other dewatering equipment. So here we see our shafted washer compactor, Aqua WashPress. It is why do we use a washer versus just a compactor? If there's a lot of organic matter in the screenings, then it's very important to have a washer in addition to a dewater, because by washing these organic solids, you can reduce the volume up to 50% and weight by 80%, and again save a lot of money in the hauling cost. And that's why we use Aqua WashPress where there are high organic solid concentrations. Here again we see the Aqua WashPress, and we call that pipe there the lazy ass design. That's actually giving us a lot of the compaction that we need to dewater the solids. And now we are looking at our hydraulic piston HyPress product, which uses a hydraulic piston, or we call it a ram press. There are several names in the industry, that basically pushes the solids further by just using a hydraulic packing gland. And again, the dewatering occurs because of the solids in the pipe, and then the most important feature for this piece of equipment is that you can really push solids far away, up to 30, 40 feet away if you need to. And our shaftless spiral design is the helix press, we call it. The most important feature for a difference between shafted and shaftless spirals is that we have less strength than shafted spirals, but we can carry very large solids, as you can see in that picture. And it is much better for stringy material. If you have a long stringy material, that tend to strap around a shafted spiral, where a shafted spiral doesn't care. It's better for those material. And here we see an installation with 2 Aqua guards and a helix press. As you can see on the shafted spiral designs, that you cannot have multiple feed points typically, but with helix press you can have multiple feed points and feed multiple screens into one conveyor or dewaterer. But you cannot have any pipe connection, so you cannot do any turns or drag the screenings in another direction. So you would need another conveyor if you have to move it to somewhere else. The last thing that we're going to look at is sluicing. This is something we recently started offering, and we are using you can use basically recycled water from the plant, and it also allows some washing. What sluicing is, basically, the collected screenings are pushed with basically water in a sluice trough. It's just a trough, and you push them with water instead of any mechanical piece of equipment. And what is the advantage of this is you don't have any mechanical parts to maintain, and you can just use a pump to convey solids. And you have to select the right dewatering equipment, which we recommend right now is the Aqua WashPress, to handle all that flow that's coming with the screenings while we're moving them around. And that's going to be it from me today. If you have any questions, I'd be happy to answer.
What is the selection criteria that would determine whether you would use a Rotoshear or a Rotostrainer?
Well, there are a couple different criteria that we should look at when selecting the screen. Rotoshear definitely has hydraulic capacities, and it also can handle higher solids concentration and larger solids. It has heavy-duty designs, but Rotostrainer, for example, can be very good with high fat, soils, and grease levels. The application engineers that you're dealing with would know all of this information and can direct you in the right screen selection.
How many installations do we have at membrane plants?
We currently have a total of 15 membrane installations, and there's 5 or 6 more of them in the pipeline right now. There are a lot of them in the West Coast, probably 7 or 8 of them, and we also have the largest membrane plants in the country. Coldy Creek Water Reclamation Facility is one of them in Duluth, Georgia, which is a very famous and important one. We have Oakley, California. We have Modesto, California, and we are capable of using our screens with all of the different membrane manufacturers.